We're going to go through a few conceptual questions in this video. These questions are going to be specifically related to electromagnetic waves. So an oscillating charge will create an electromagnetic wave. So here is our first question. The correct answer here is B. The direction of E cross B gives us the direction the wave travels in. So in this particular case, they tell us this electromagnetic plane wave is coming towards you. So towards you or me. So with the right-hand rule for cross products, the way our author has done it is to put our thumb of our right hand in the direction of whatever is first in the cross product. And so that would be the electric field. Our pointer finger or index finger needs to point in the direction of the second vector, B, which we're not sure of yet. If we're holding our thumb, index finger, and middle finger perpendicular to each other, then the result, in this case, the direction the wave is traveling in, needs to point towards us. Now, the orientation of the hand I just attempted to draw is not quite right. We need our thumb to point to the right. The problem tells us that the electric field looks as shown on the right. So the electric field is pointing to our right. So point your thumb of your right hand to the right, towards the right side of your screen. We don't know the pointer finger yet, so let's jump to the direction of the wave travel. We know that's coming towards us. So out of the screen. So you should have your thumb pointing to the right. You should have your middle finger pointing out of the screen. If I'm holding my thumb, index finger, and middle fingers perpendicular to each other, then my pointer finger, my index finger, points this way. Since the pointer or index finger represents the second vector in the cross product, specifically the magnetic field vector, that's why B is the correct answer. So we have plenty of right-hand rules, equations. This is still the same right-hand rule for all cross products. We're just applying it to a new equation. Here is another question for you. What do you think about this? The correct answer here is C. So intensity is the same thing as the S average. If I look on the test notes, one way we can write S average is in terms of the maximum or peak electric field, which also means amplitude of the electric field. So if I want the left side to double by changing E, if I want to get a 2 times all of this original stuff, I'm going to ignore these constants in front. I'm not changing those. That's just part of the equation. If I want to pull the 2 into the E naught, like this, and then square the whole quantity, then it needs to be the square root of 2. Because if I take the square root of 2 squared, then I get my 2, and then the E naught squared. So this is how I get it to double, is by increasing the value of just the electric field itself, and increase that by the square root of 2. One more question. Correct answer here is A. Now, side note, electromagnetic waves are often called electromagnetic radiation. When we talked in the first semester of physics about ways that heat could be transferred, we had conduction, convection, radiation. Radiation is saying that it's these electromagnetic waves that are carrying the energy away. So radiation, not necessarily talking like radiation therapy per se of cancer or something like that. To give us a visual of what we might be meaning here, our point source could be, say, a light bulb. It's an ugly light bulb, but there you go. It tells us that this light bulb is emitting, or whatever the source happens to be, it is emitting its energy and power in all directions uniformly. So when we talk about intensity being power, the power here says this point source is P naught. If it radiates in all directions uniformly, then we would divide that by the area of a circle, a surface area of a sphere, 4 pi r squared. Now, at some distance r away here is our detector. The detector is receiving this intensity. The intensity received, I'm going to put received for the power per area of the detector. This is the intensity. The detector is receiving this intensity. The intensity it's receiving is from the source. So we can say this is power received divided by the area of the detector. So the question is asking for the power received. So the intensity of the radiation emitted times that area, just bringing the area up here, will give us the power. And that's why A is the correct answer.